This is the answer key for the Test 2 review in Math 117. The first question is, what is marked equilibrium? That is where supply equals demand. Where supply equals demand. This also is the intersection. So you want to think about what you would do to find that market equilibrium. It's about doing the intersection on your calculator. Number 2, list the structures on a graph that cause the limit to fail. Well, that's jumps, vertical asymptotes, and heavy oscillation. You could put OSC period. Number 3, sketch the graph and state the domain and range of each. So for A, y is equal to 3, y is equal to 3. The domain is all reals. The range is 3. In braces would be best, but the braces aren't necessary. You can see that. That's the x-axis. Part B says x is equal to -2. So that means that the domain is -2 and the range is all reals. Part C is a line, and the y-intercept is 3. The slope is -2 3/2, so I'm going to go down 3 over 2, connect the dots. It's not a vertical or horizontal line, so the domain and range are both all reals. Now you could write -infinity to infinity here for the all reals, but the double-lined R is fine. For the next one, it's a parabola, and if you graph this, you can see it's a parabola. The lowest point on it is 7, so I'm thinking I'm going with y values starting down and going up. So the range here is from -7 to infinity. The last one is a square root graph, so I'm going to my calculator to do this one. So go to y equals, hit clear, and do second square root of 7 minus x. And I need to get out of the square root, or if you have a TI-83, you need to close the parentheses, plus 3. Now you could do this by hand, and that would be fine. And then we'll do a zoom 6, because I'm not sure what I was doing the last time I was in here. And I've got a graph that looks like this. So what I know for sure is that when I put x equals 7 in here, that's going to be my the largest number I can put in. So 7, and then y is equal to 3. So that gives me that point out here on the graph. It gives me the bottom point of the square root graph. So 7, 3, 1, 2, 3, 4, 5, 6, 7. You don't need to put a whole bunch of tick marks on, just the ones that are relevant. 3. So I need this, and then it swishes this way. That's all I'm going to need for it. So the domain is from -infinity to 7. We're including the 7, because we could put 7 in, it gives me the square root of 0, which is 0, but I never include the -infinity. And the range is from going up the graph like this. 3 is the smallest one, 3, and I do include it, to infinity. For question 4, we are combining functions. So f times h is just, it doesn't say to simplify this, will be 2x cubed minus 5x squared times h would be the square of 2, and it should be w there. Sorry, there's a typo. So it should be 2 over 3x plus 3. I could put that in parentheses if it makes me feel a little better. G minus f rather, is the square root of x squared minus 10 minus f is, I need this in parentheses, 2x cubed minus 5x squared plus 10. For part C, it's w over g, so it's 2 over 3x plus 3. Over g is the same thing as 1 over 1 divided by g, so I can really just do 1 over g, which is the square root of x squared minus 10. You might feel more comfortable with parentheses, that'll work. So w divided by g is the same as w times 1 over g. For part D, f of g means I'm going to the f equation. Everywhere I see an x, I'm putting g. So this is 2 square root of x squared minus 10 cubed minus 5 square root of x squared minus 10 squared plus 10. The last one is g of w. I'm going to put it down here. G of w is, go to the g equation, that's a square root. Everywhere I see x, I'm going to put w. 2 over 3x plus 3 squared minus 10. For the next one, we want w of negative 1, where w is g of f. And I wrote that backwards first, but it's all right. So that really means I want f of negative 1. So I want g of f of negative 1. If I put negative 1 into 2x cubed minus 5x squared plus 10, that'll give me negative 2 minus 5 plus 10, which is g of negative 7 plus 10 is 3. Now I go to the g equation, and I'll have the square root of 9 minus 10. So this gives me the square root of negative 1, which is actually I. I'll be very careful on the test that I don't give you imaginary numbers to calculate there. I was not very careful here. So part G, I want w of 2, where w is equal to f of g. So that means f of g of 2 is what I want. So I want g of 2. If I put 2 in, I have the square root of 4 minus 10, which is negative 6. Again, I apologize for that. I did not mean that. So I'll be more careful on the test. So then we have f with the square root of negative 6 put in will be 2 square root of negative 6 cubed minus 5 square root of negative 6 squared plus 10. So if you get some weird number, you just keep working with it, you get full points for something like this. For part H, this is a bonus part, so there'll be 110 points on the test, and you could really consider that anything on the test is bonus. But on this particular one, we want to find f of a plus h minus f of a. So I was teaching this as doing f of a plus h, which would be f is 2 times a plus h squared, cubed rather, minus 5 times a plus h squared plus 10. So this equals 2 times a cubed plus 3a squared h plus 3ah squared plus h cubed. So you can memorize that part for the cubed. Minus 5 times a squared plus 2ah plus h squared plus 10. So this equals 2a cubed plus 6a squared h plus 6ah squared plus 2h cubed minus 5a squared minus 10ah minus 5h squared plus 10. So I'd expect to see that for full points towards this bonus problem. So I also need f of a, and f of a is just 2a cubed minus 5a squared plus 10. Now every time I do this procedure, everything in f of a is going to go away from the line above. So I'm subtracting off this. So from this I'm subtracting. So this goes away, the 5a squared goes away, and the 10 goes away. And you can catch some errors if you're careful about it, because you'll be able to see that you should have written maybe something differently in f of a plus h if these don't go away. Now the next thing to do is f of a plus h minus f of a over h is to factor out an h, because I want to get rid of that h. So h, I'm left with 6a squared plus 6ah plus 2h squared, taking an h out of each term here, minus 10a minus 5h all over h, and that goes away, and I'm done. There's my answer. Number 5 says that you're manufacturing blank DVD disc, and you have a monthly fixed cost, so that's f of x equals $11,250. And a variable cost of variable X of 68 cents per disk. So I need an X in there, so that's 0.68 times X. Find function C of X that gives the total cost. So C of X is equal to 11,250 plus 0.68x. That's really all you need to put there. When I ask you for a cost function, revenue function, any kind of function, I'm expecting to see what the function is called, C of X, and the equals to. If you leave that out, you'll lose a point. So make sure you're putting that in. Number 6 says we have a Chapman Corporation, and they have a fixed cost of $11,500 and a variable cost with a function in there. So first we want the total cost function. A, that's C of X equals the fixed cost, $11,500, plus the variable cost, which is point with a bunch of zeros. This is pretty typical in business to have a bunch of really interesting little decimal numbers here. Minus 0.02x squared plus 60x. So that's part A. Part B says what's the revenue, what's the total profit, and they give you a revenue. So the total profit would be P of X is equal to the revenue minus the cost. So the revenue function they give me is negative 0.03x squared plus 140x minus the cost. And I'm going to put these in parentheses. I don't have to have it simplified. I don't need you to simplify it. You can if you need to. I don't need you to. But it does need to be in parentheses to get it correct. Part C wants to know what's the profit for 3,700 units. So that's P of 3,700. So we'll go to the calculator for that one. So we need our profit function, and put that in to our calculator. Clear my main screen, and all I want to do is put 3,700 stores to X. So remember that the store to button is down here. 3,700 stores to X. We end up with this stored there. I'm only doing this one time, so I only need to do it once on my calculator. So I'll put negative 0.03x squared plus 140x So I type in the whole equation that I had when I wrote it down in part B. I hit enter, and it's going to put the 3,700 in. And I get 96,947. Now I want to go back to my problem, and it says, what's the profit or loss? And it says X pagers per week in dollars is represented. So we definitely don't have any thousands that I have to deal with. So the answer here is just going to be 96,947 dollars. For the next problem, I have some formula that I'm going to put in y equals so that I can evaluate it a couple of times. So the first one says that 2003, which they say is 2t equals 0. And then the second one we want is at 2008. So if t equals 0 and every 1 is a year, t equals 1 would be 1 more year. 8 minus 3 gives me 5, so this should be t equals 5. Now the x also is supposed to be in units of 1,000. So I can go to my table, second table set this up at 0, the delta table to be 1, and then look at the table, second table. And this will give me both my answers. This is 47.4, and this says 1, 2, 3, 4, 5, down here 103.37. Now each of these will have to be multiplied by 1,000 because we're in units of 1,000, so I actually want to tell how many I've made. So I'm going to scroll over here and see if there are any more decimals, and they're not. So the first answer here will be x equals 47,400. And the second answer, according to this graph, if I just scroll down now, scroll one too many, will be 103,370. So 47.4 for the first and 103,370. When you're asked for units, you probably ought to round to the nearest whole number, but if you put 3 decimals, that'd be fine. Here the answers need to be either 47.4 thousand or 103.37 thousand, or you could do like I did, 47,400, 103,370. For number 8, we're going to put the two supply and demand functions, and the supply function is the one that's a negative x squared because supply usually goes down. It starts with a higher price and then the price goes down as the quantities go up. So in y1, y2, and then we're going to do second trace 5, enter. So let's look what that looks like. See what that looks like. So we have in y1 and y2 we have the two equations. We'll do second trace, intersect 5. And I can't really see the graph, so I know that I'm going to reset my window to maybe be 0 to 20, because I want my x values. And then if I do a zoom 0, and you could scroll down to see it says zoom fit, I can see I'm still not got big enough x values there, so I'll need a larger x value. So I'm going to go to maybe 50, see if that works. Not quite. So I'll set my window again, go to 80. And now I can see that intersection. So you won't be able to find the intersection on your graph unless you actually are able to see the intersection in your graphing window. So second trace 5, and then it's going to ask you first curve enter, second enter, guess enter. So you're just doing enter. And it tells you the intersection is 54 and 706. So I get x equals 54 and y equals 706. Then I need to write a statement saying what I think the production recommendation should be. So I suggest making 54 units, and in this case it's upscale lamps at $706 each, which is more than I'd be willing to pay for a lamp, but they must be pretty nice upscale. I notice I actually skipped a problem. This should be number 9, and then 8 said x is in units of 1,000, and we have a price equation, and we want to know the price when the supplier will make 1,200 units. So that means x is actually 1.2, because x will, they say, will make 1,200 units. That's 1.2 in terms of 1,000, 1.2 thousand. So we want p of 1.2. So if I go to my calculator and I put this in, it's pretty easy just in the regular menu here. I'm going to put 1.2 stores to x, enter, and then I'll put my equation which said x cubed plus x plus 14. To the third, go over, plus x plus 14. I'll check one more time to make sure that I have it right. X cubed plus x plus 14. Hit enter, and I have my answer. So this is 16.928. Now I want you to put 3 decimal places for prices. So 16.928 should come in here. So this should be dollars. 16.928. In number 10, we just want to know which one the linear equation is. So we're going to state the letter of the linear equation and then write it in mx plus b form. So number 10, the first one has a cubed in it, so it can't be a line. Part B has a square in it, it can't be a line. Part C only has one x and one y, so it can be a line. And part D has a square in it, so it cannot be a line. That's how easy that is, so don't overthink it. So this is part C, and we have negative 6x plus 4y minus 7 equals 0. So that's almost standard form. So we want to solve for a y in this equation. So if I solve for a y, I'm moving everything else over. I got 4y is equal to 6x plus 7. So I'll have y is equal to 6/4 x plus 7/4. And you should reduce the fractions when you can, the 6/4. So y is equal to 3/2 x plus 7/4 would be the best answer there. For number 11, we want to determine whether the function's polynomial, rational, or other. So rational means you have things in the denominator that are not radicals. Polynomial means there's no denominator other than 1. And then if you have a radical, that's not a rational function or a polynomial function. So for part A, that's just a polynomial. Part B, we have just a polynomial. And I'll go back and talk about degrees in a second. For part C, I have a rational, because the x to the negative fourth would go to the denominator, so we end up with things in the denominator and no radicals. Part D is a polynomial, and then part E is another, because it has an irrational there, square root of x. It has a radical. So this is other. So going back to the polynomials, the first one has the highest degree is 2. The second one has x to the 8th to the 3rd, which would be 24. 8 times 3 gives me 24. The third one has a third and a 1 together, so actually it's the fourth one. Has a third and a 1 together. So that's 4. Actually, it's a fifth and a 1, so that's 6. And if you need any more help with that, be sure you get in touch with me in my office hours. For part 12, it's required that you put the c of x, r of x, p of x. So make sure you're doing that. The cost function here says it has a fixed monthly cost of $34,000 with a variable cost, a production cost of $9 for each unit, plus 9x. It says that the production cost, the product sells for 11 per unit, so that would be 11x for the revenue. So each of those pieces goes into one or two slots. It's either revenue or cost. So you separate them out that way. The profit function then would be the revenue, which is 11x, minus parentheses 34,000 plus 9x. Now you can tell already that you're going to have to make an awful lot of units in order to get 34 to get a positive revenue. So looking at the next two, they want to compute the profit or loss corresponding to a production level of 7,000. So I notice here it'd be pretty easy for me to simplify this, so it might be easier to simplify. That's plus 11x minus 9x gives me 2x. So I've just got a little linear formula here that's pretty easy to put numbers into. So part D, I'm doing the profit of 7,000 units. In part E, I'm doing the profit of, or loss of 11,000 units. So I'm just putting 7,000 in here. That's 34,000 plus 2 times 7,000. That's a negative. That should be a negative there, which is one of the reasons I don't always do a simplification of the problem, because I'm liable to pick up errors. But then if you only made that error, it'd be minus 1, so it wouldn't be too bad. So this is minus 34,000, if I could write, plus 2 times 11,000. So we'll go to our calculator and figure those. So for the first one, I got negative 20,000, which is a loss. And for the second one, I got negative 12,000, which also is a loss. For number 13, I need to graph the piecewise function here. So I'm going to put y1 equals, it says to put what I'll put in my calculator. So it says y1 equals, I need parentheses, 8.37x plus 7.44, parentheses. Now I have to start with the x. It's greater than or equal to 0, and x is less than or equal to 8. Plus, and I'll put the second piece under here because it'll be easier to see. I forgot my parentheses there. Make sure you're putting that one in, because if you leave it off when you graph, you're not going to be able to see your graph. Plus 51.68. Now you can get function values off of this without doing the graph, but the graph is part of the points, and I do expect to see what you put in your y1. So whether or not you do it by hand is up to you. So, and then the second one will be x is greater than 8, and x is less than or equal to 30. So I can see I want to set my window to be for x is between 0 and 8, and then do a zoom 0 for zoom fit when I put this function in. Just putting in one function into y1. So let's go to y1 and put this in. So we're just typing straight across. We want x is greater than or equal to, we find that in second test. In this case it's 4. We want 0. And to get the and, we need second test. we're going over to logic and grabbing the and. So we do x is less than or equal to second test less than or equal to, which is 6. We need an 8 there. We close parentheses. We need a plus. So when you finish putting the whole thing in your calculator, then you'll go to your window, and we want it to go from 0 to 30. And you might put -1 to 31, but 30 is fine. You just need to get the general shape of the graph. I'm going to do a zoom 0 so that it fits the best graph for me. So I'll go to my paper and draw this graph. Looks like this. And that'll be good enough for a sketch of a graph. I don't need tick marks or anything. You might put in a 30 just because, and an 8 just because. That would be the best graph. So we need 2 function values, and we can get them on the calculator now since we have it in the graphing menu. But we need the right x values, or t values in this case. So we want for 1972, which would be f of 2, if every year is going, and it does say years, not decades, so you look for that. Some of your problems have said decades. And then 1993 would be 23, if you need to do that subtraction. So I can go to my graph, second calc, and actually calculate the value here for my graph. I've got 2. Of course, you could do this from the table, but I kind of like to see it on the graph. This would be 24.18. So that says that the price of ivory is 24.18, and that would be dollars. It says in dollars per kilogram. So then I can do that again, second calc, and I want it for 23. Hit enter. I must hit the wrong thing, second calc. I want the value for 23. Hit enter, and I got 117. So this is $117. For 14a, we have an infinite limit. So the limit as x goes to infinity of 2x cubed plus 5 over x plus 1. And it says if we're doing an infinite limit, there's a theorem that we can get rid of everything that we don't actually need. So we'd have 2x cubed over x. And you keep writing limit until you actually take it. I haven't put infinity in yet, so I haven't taken it. So this is the same as writing the limit as x goes to infinity. I can reduce one of the x's, 2x squared. If I put infinity in now, I get infinity. Now if you understood that it was going to be infinity right away, you could put that. Just make sure you have the correct sign when you do it. Part B, the limit as x goes to -25 of pi is pi. So it doesn't matter what x is doing, my value is pi. My function value, f of x. With the limit as x goes to 1 of 2x plus 5 over x minus 11. So if I put this 1 in, notice I don't have a problem in the denominator, so I can just put it in. 2 times 1 gives me 2, plus 5 is 7. 1 minus 11 is going to give me a -10. And I'm done. D, I'm doing another infinite limit. So it'd be the limit as x goes to infinity. All I need is the 2x over 3x squared. And I can see that this is going to be, that looks terrible, is going to be the limit as x goes to infinity of 2 over 3x. If x is in the denominator, this means x is getting bigger and bigger. So this would be 2 over 300, 2 over 3,000, 2 over 3 million. This one is going to 0. For part E, I have the limit as x goes to -infinity. So that means I can just take the highest powers in the numerator and denominator, which is 2x squared over 3x squared. See the 3x squares, both the x squares go away, so I'm left with 2/3. For part F, I need to do the conjugate trick, or I could put this in my calculator. And for the purposes of the test, I think we'll do these in the calculator. So for part F, I'll need to go to y equals, clear this out, and I'll put in the square root of 30 minus x. Now it's in a numerator, so I need parentheses for a numerator. Second square root of 30 minus x. Now note that if you have a TI-83, it opens up a parentheses for the square root, and you'll have to close that. I have to go over out of it. 30 minus x minus 5, close the parentheses, divided by parentheses x minus 5. Now, this gives me a way to evaluate it, but putting in 5, I can see that I get a 0 in the denominator and a 0 in the numerator. So I've got a problem here at 5. So I want the limit at 5. So I'll go to second window. I'll put in 5 as my starting value, and I want it real close to 5 so that I can see what the number is. So I'll put 0.00001. If I do a second table here, I can see that this value is negative 0.1. And if I go below to the left of 5, just a little before 5, below 5, I also have negative 0.1. So my answer for this problem is negative 0.1. For the next problem, we can get the answer by factoring. If we put negative 2 in both of these, we end up with 0 over 0. So if I factor the top, the limit as x goes to, I haven't taken the limit yet, so I have to keep writing it. This is factored as x minus 3, x plus 2, and we have x minus 2x plus 2. So if your factoring is pretty sharp, you might want to go study it up if it isn't, but if it's pretty sharp, this is fast. So we end up with a negative 2 going in. We get negative 2 minus 3 gives me a negative 5 over negative 2 minus 2 is negative 4. The negatives reduce, I get 5/4 for my answer. The next one, if I put 5 in, there's not a problem, so I can just put this in. So this is a square root of 9 minus 5 over 5 plus 4. Notice I did not write the limit because I'm actually putting the 5 in. 5 plus 4 is 9. So we end up with 3 minus 5 over 9, which is 3 minus 5 is a negative 2 over 9. Negative 2/9 would be the best answer. Now I don't want decimal answers for the limits, if you can get them to be an exact number. Negative 0.1 for the last problem actually was an exact number. This would give me negative 0.22222, so that's negative 2/9. Putting negative 4 in, I might go to my calculator to do this to remind you of the steps. So I quit out of here, I'm going to put negative 4 stores to x, enter. And basically, unless you get this right, there are no extra points or partial credit here unless you tell me that you put exactly what you put down for how you're going to do this problem. So I do 3x to the third plus 4x minus 1, enter, and that gives me negative 209. This is negative 209. Now the intermediate steps would be 3 times a negative 4 cubed, and I have to have the parentheses, plus 4 times a negative 4 minus 1 rather, which gives me a negative 209. That's what we got on the calculator. So if you have any questions about the review, be sure to see me in my office hours or make an appointment. I'll be ready for the exam at 8 o'clock in the morning, so make sure you're ready by 8 o'clock. Coming in late probably isn't a good idea because all it's going to do is have you more rattled.